Good morning, Honors Algebra 2. This is a video for our Monday back at school. Hopefully you had a great winter break. I know it was awfully chilly the first few days. I sure did enjoy Florida, seeing my grandson and my son and daughter-in-law. Played some golf and enjoyed the beach with my wife and so forth. All right. We are now moving into a new section. So we're still in Unit 5, but we're in Section 2. And this section is about dealing with life, world problems in regards to interest and so interest types of problems. So we've got like 4 days of learning on this kind of stuff. So here we go. How do we find the principal or the balance in an account where the interest is compounded annually, meaning on a yearly basis? Given a real-world problem, how do you write a linear function or an exponential function? So that's kind of what we're looking at, is various kinds of functions in this section. So first off, compound interest problems. Pretend you have $1,000 in a bank earning 6% annual interest. How much money would you have at the end of the first year? So basically what you're going to do is you're simply going to take that money, 1,000, and if we're earning 6%, that means we're getting 100% plus 6%. And 100% plus 6% gets you 106%, and as a decimal, 106% is 1.06. So multiplying those two gets you $1,060, okay? $1,060. All right, what about at the end of the second year? So you take that $1,060 and you multiply it by another 1.06, right? And you get $1,123.60. And how much money at the end of the third year? Same thing. You then take that $123.60 and multiply it by another 1.06. And you'd have almost $1,200, $1,191.02. How much at the end of T year? So meaning any kind of year. So you would multiply 1,000 times 1.06 raised to the T power for whatever year you wanted. Okay? And so this is how we generalize then that formula. Okay? For this problem of putting $1,000 in the bank at 1.06, meaning 106%, of X years, that would have been back in Algebra 1, exponential. But this is how this is as far as a principal type problem. The amount equals your principal. The principal stands for the money that you're putting into the bank, times then the 1 plus whatever the rate is. That's why when it was 106%, it was 1 plus 6% is 0.06 as a decimal. So 1.06 raised to the T. All right? So that's a formula that we need to get memorized. All right? The amount equals principal times parentheses 1 plus R raised to the T. Okay? So here's a new problem. We start with a sheet of notebook paper that is 0.0032 of an inch thick, 32 ten-thousandths of an inch thick. You start with one sheet, you double the stack 25 times. Guess how tall the stack of paper will be in inches. All right, so double the stack once, that means you have 2 sheets in the stack now. Double the stack twice, so 2 sheets was stacked once. Double that, you've got 2 squared of 4 sheets. Double the stack 3 times means 2 sheets double stacked 3 times. That's 2 cubed, in other words. All right. And then you get 8 for that. Double the stack 4 times. That's 2 to the 4th. Gets you 16. If you double it 25 times, that's 2 raised to the 25th power. Okay? What is 2 raised to the 25th power? Let's make that so you can see that better. All right, let's put the commas where they go. 33,554,432. So, as far as completing the chart, when we doubled it once, we had 2. We doubled it twice, we had 4. Doubled it 3 times, we had 8. Doubled it 25 times, we had that 33,554,432. So, taking that number and multiplying it by 0.0032 gets us let's see. Put the comma right there. 107,374.1824 inches. Okay? So what is that height in terms of feet? So you take 107,374, right? Divide that by 12. All right? Take that number. Hold on. Having difficulty seeing the whole thing. Take that number and you would divide that by 12 to get 8,947 feet. What is the height of stack in miles? So divide that by 5,280. Because there's 5,280 feet in 1 mile and you get 1.69 miles. What kind of growth is illustrated in this problem? This is considered exponential growth. All right? So to generalize the formula, down here, y equals 1 times 2 raised to the x. Okay? 1 times 2 raised to the x. And so here that would be y equals c times a raised to the t. All right? Y equals c times a raised to the t. All right, so let's go to the next page. Another story problem. Which salary plan is better over a period of several years? Now, this is going to be similar to homework 5 through 8. So that first page, the first example that we did, compound interest problems, is going to be very similar to homework numbers 1 through 4. Okay? So now this is going to be similar to homework 5 through 8. All right, so which salary plan is better? Option A, starting salary of $24,000. Notice option B, starting salary is the same. Each year on salary option A, you get a 4% raise each year. Or option B is you get a $1,000 raise each year. Okay? That's the two options. So let's kind of look at your plan is to save at this job for, let's say, 30 or more years if you stay at that place. So You would like to think that probably option A is going to be better, getting a 4% raise. Think about 24,000, getting a 4% raise. Okay. So let's kind of go through this. So Y equals our amount, 24,000, times our rate, the 1 plus the rate, right? 1 plus R in the parentheses, raised to the T, right? Well, this is an X for right now. So 1.04 is 100% plus 4%. All right? So after the end of X years, so at the end of the first year, you would then get $24,960 for that next year. All right? What is your salary at the end of 10 years? It would be $35,525.86. Because that would be 24,000 times 1.04 raised to the 10th power. Okay? After 10 years. I guess the C maybe stands for your cash. I don't know. 1 plus R raised to the T. All right. What is your salary at the end of 10 years? $35,525.86. After 30 years, your salary would be $77,841.54. So almost $78,000. Okay, that is showing us exponential growth. Okay, now as we continue on, here's option B. 24,000, you get $1,000 each year. So that would be Y equals 1,000 times however many years plus 24,000. All right, so after 1 year, 1,000 times 1 is 1,000 plus 24,000 makes 25,000. At the end of 10 years, put a 10 in there. 1,000 times 10 is 10,000 plus 24,000 makes 35,000. At the end of 30 years, 1,000 times 30 is 30,000 plus the 24. 24 plus 30,000 would be 54,000, not 55. Okay? I guess that would be for then your 31st year. I don't know. Y equals mx plus b is a linear growth. All right? Y equals mx plus b. That's linear. So this is illustrating hopefully what you learned back in Algebra 1, that exponential growth is a growth that, is going at a curved rate. An exponential growth is a curve, whereas linear growth is a line. And the more that you go to the right, the more years, the more possibility for income increases drastically with exponential more than linear. All right? So it is going to now ask us several different questions here. I'll zoom in a little bit. Which salary plan is better? Obviously, having a 4% raise. Linear growth increases at a constant rate. Exponential growth increases at a percentage rate, or at a, I'm trying to think maybe what they would have said back in Algebra 1. It's just an ever-increasing rate because of the curve, all right? So let's go through. In 1975, the hourly wage of school cafeteria workers was $2.53. For the next 15 years, their wages increase by 23 cents each year. Wow. This is similar to homework number 9. Write an equation that represents their hourly wages at the end of X years. All right? So at the end of X years, think of how we're going to do this. All right, is this linear or is this exponential? 23 cents each year. So that's every year. So that's just going to be 0.23x plus 253. All right. So that's linear. Their hourly wage in 1990 was $5.98. That's what it would be in 1990, okay? $5.98. What kind of growth? Linear. During the same years, the cost of living increased by 6.2% each year. Can you write an equation for that represents the cost of living? That would be y equals 1.062. All right, so notice 6.2% is written as, move the decimal 2 spots to the left and take away the percent symbol. So that's where you get the 0.062, because you're moving that decimal 2 spots to the left. And they started with $2.53. That's why the 2.53 is at the end. This is linear. What would their hourly wage be in 15 years? So if you put a 15 there, 15 times 1.062 plus $2.53 would be $18.46 would be their hourly wage. So this, what kind of growth is the cost of living? The cost of living is an exponential growth. Did their hourly wage keep up with the cost of living? No. Okay. All right, so let's finish the bottom of this page. Suppose that 10 grams of plutonium is released in a nuclear accident. The half-life of plutonium is about 25,000 years. So this is very similar to a science type problem. How much plutonium will remain after the first half-life? All right. Well, if we started with 10 grams, all right, and it has a half-life of 25,000 years, how much plutonium will remain after the first half-life? Take that 10 grams, cut it in half, right? 5. How much will remain after the second half-life? Take that, cut it in half, 2.5. And so when we complete the chart, the number of half-lives with 0 half-lives, that's what we started with, 10 grams. After 1 half-life, 5 grams. After 2 half-lives, 2.5 grams. 3 half-lives, take that, cut it in half, 1.25. After 4 half-lives, cut that 1.25 in half, and you get 0.625, and so on, right? So do you see a pattern in the chart? We're dividing by 2 every daggum time. How much will remain after the 10th half-life? So if you kept doing that, cut that in half, cut that in half, cut that in half, cut that in half, till you do it 10 times, you would get 0.00977 grams. So here is the formula for that. Y equals what you start with times a half raised to the x power. So it's just like the principal one, basically, except we're not dealing with adding a certain rate to 100%. We're, in this case, our number that we're dividing by is, or or cutting it in half every time for however many half-lives, for however many times. So y equals 10, parentheses, 1/2 raised to the x. Well, that is similar to the y equals c, your cash, right, times the amount raised to the t. I need to try and think through what this c really stands for. Maybe I'm right. I don't know. Okay? Next page. Which of the following equations represents exponential growth? Which equations represent exponential decay? So growth and decay. All right, so 3 times 0.98 raised to the x is going to be decay. 3 times 1.03 raised to the x is growth. Notice, what makes it decay, what makes it growth? It looks to me like, let's go to the third one and the fourth one first. Y equals 1/2, then times 6/5 raised to the x. That's growth. The fourth one, y equals 1/2, then times 3/4 raised to the x is decay. So to me, as I look through all of these, focus on whatever is raised to the exponential power. All right, so I'm going to circle those things that are raised to the x power. This number that's raised to the x is 0.98. That's a smidgen below 1. This number is 1.03 raised to the x. That's a smidgen above 1. 6/5 is above 1, right? 6/5 is 1 1/5. 3/4 is another way of saying 0.75. That is less than 1. So the base number that is raised to the x, if the number is less than 1, it's decay. If that number that's raised to the x is a number greater than 1, this base is 1.03, it's growth. This base number is 6/5, growth. This base number is 3/4, decay. So that's how you determine growth or decay. Look at the base number. Above above 1 growth, below 1 decay. Remember asymptotes? The graph keeps getting closer and closer to a line called the asymptote. But the graph never touches or crosses the asymptote. So graph the asymptote by making a dotted line. Why? Because it cannot touch that line. And so here we have y equals 3 raised to the x. All right? So if we pick some numbers, a -1 for x, 3 raised to the -1 is 1/3. 3 raised to the 0 is 1. Remember, any number raised to the 0 power is 1. 3 raised to the first power is 3. 3 squared is 9. 3 cubed is 27. So notice the growth. This is just a quick sketch. When it crosses the y-axis, it's at a height of 1 right there. And as you go 1 to the right, you're 3 high. 2 to the right, you're 9 high. 3 to the right, 27 high. So this is just simply showing you exponential growth. The graph looks like that. Okay? And then y equals 1/3 raised to the x. So the base is 3 here. The base is 1/3. All right? So 1/3 raised to the -2 power, is 9. 1/3 raised to the -1 power is 3. 1/3 raised to the 0 power is 1. 1/3 raised to the first is 1/3. 1/3 squared is 1/9. So this is illustrating decay. If you were to punch that into your graphing calculator, your curve would look like that. Okay? And of course, this is our asymptote, y, not x, y equals 0 and y equals 0. It will not cross that line. Okay? So please understand, this is growth, this is decay. And so sometimes these can be tricky because remember, if you can have a growth scenario, but have a negative leading coefficient, like if this was a negative, or maybe there was a negative a half multiplied by that, it causes that then to reflect over the x-axis, and so this curve would be going like so, and you might think that's a decay, but it's just the reflection of a growth graph. And same here, you could have this, have a number maybe multiplied, a negative number multiplied to that, and that would reflect it over the x-axis. And so something that goes up like this might look like a growth, but it's just the reflection of a decay, all right? So just wanted to make you aware of that possibility. All right, so as we summarize, match the equation to the following situations, all right? The amount of money left in a savings account after several years where the interest is compounded annually is A. The amount equals the principal times 1 plus r raised to the t power, okay? Number 10, the number of graduates from Etowah High School increases by 25 students each year. That's going to be very similar to E, y equals mx plus b. 11, the number of graduates from Etowah High School increases by 2% each year. Y equals c, parentheses, 1 plus r raised to the t. All right? And then the number of graduates from Etowah High School decreases by 2%. So that's like letter C. Y equals C, parentheses, 1 minus r, decreasing by 2%. 1 minus r raised to the t. And then the number of, or a virus triples within 24 hours from the time it enters your body. That would be D, Y equals C times A raised to the t power. All right? So I would focus on these kinds of formulas here for doing the homework. And that is the lesson, folks. Hopefully you, if you're at home, unfortunately, you're not able to be here. And so, anywho, hopefully you had a great break and you understood this lesson. Not too bad. It's using your calculator a lot and so forth. So get after it, and maybe we'll see you tomorrow. Peace out. Miss you guys.